Welcome to the deep dive. Today, we're looking at something really fascinating, I think. Rain-powered solar technology.
Yeah, it sounds a bit like science fiction, doesn't it?
It really does, and specifically its potential in variable climate places like Fargo, North Dakota. Pretty surprising.
Absolutely. So our mission today is really to unpack how this works, where the tech stands right now, and what it could actually mean for getting consistent renewable energy.
Even when it's cloudy or raining.
Exactly.
Hmm.
We've gone through some pretty interesting research to piece this together for you.
Okay, so let's start with the basics. Rain-powered solar. How does a simple raindrop, how does it become an energy source? Walk us through that.
Right. So the core technology uses these things called triboelectric nanogenerators, or TANGs for short.
Thanks. Okay.
Yeah. Think about static electricity, like rubbing a balloon on your hair. It's basically that same principle, just, on a tiny scale. These tangs are designed to take the kinetic energy, the impact of a raindrop hitting a surface, and convert that into an electrical charge.
Wow. So like every single drop is a miniature power generator.
In a way, yes. The specific process is called liquid-solid contact electrification. So when a raindrop hits the panel, often made of something specific like fluorinated ethylene propylene.
Right, that FEP material.
Exactly. It's chosen because it's good at holding on to charges. So the raindrop becomes positively charged, and the panel surface gets a negative charge.
Ah, okay. So you get a separation.
Precisely. And that difference, that separation of charge, creates an electric potential. And that potential is what you can harvest. It's essentially turning friction or contact into electricity.
What I found really exciting, though, was this next step from researchers at Tsinghua University in China. They've really pushed this forward, haven't they?
They really have. They've developed these dual-purpose panels. Get this. They added a layer of graphene, just one atom thick onto standard solar panels.
1 atom thick. So the panel works for sunlight and rain.
That's the idea. And this is where it gets really interesting. They're a specific design, these bridge array generators. They're producing almost 5 times the output compared to earlier ones of harvesting raindrop energy over large areas.
5 times? That sounds like a huge leap.
It is significant. Now, we should be clear, we're still talking about very small amounts of energy, picowatts per droplet. That's tiny.
It's trillionth of a watt. Right?
Yeah, incredibly small. But the key finding here, published in the journal iEnergy, isn't just the amount, it's the improvement. That jump in efficiency, about 6.53% conversion currently, signals that maybe this could scale up. It's moving from just a lab curiosity towards something potentially viable.
Okay, so let's bring this to Fargo, North Dakota. Why focus there? Well, its climate is famously dynamic, isn't it?
Exactly. It perfectly highlights the problem this technology aims to solve. Think about summer in Fargo.
It's their wettest season, right? Almost 9 inches of rain normally, lots of thunderstorms, about 23 days on average.
And then you have spring and fall, which are the second cloudiest seasons, cloudy almost half the time.
And winter, snow, which obviously is a big issue for traditional solar panels.
A huge issue. Traditional solar panel output just plummets in these conditions.
Yeah.
On a cloudy or rainy day, you might only get 10 to 25% of the rated power.
That low. Wow.
Yeah. And during a heavy thunderstorm, it could be practically zero. And if you get more than an inch of snow covering the panels, well, you get nothing.
So you can see the challenge for consistent energy generation throughout the year.
Definitely. And that's the opportunity, right? This rain harvesting tech could potentially fill those gaps.
Turning those cloudy, rainy Fargo days from a liability into an asset, potentially.
Exactly. It's about creating more reliable, all-weather production. Now, are there challenges? Sure. Installation costs are likely higher right now. It's new tech.
And durability. How long do these things last compared to normal panels?
That's still a bit uncertain. Traditional solar panels have a lifespan of, 25 years or more. We don't have that long-term data for these hybrid panels yet. But the potential for improved year-round energy production is the exciting part.
So, thinking about Fargo again, how could this actually be implemented? Do they have infrastructure already?
They do, actually. Back in 2016, Cass County Electric Cooperative set up the Prairie Sun Community Solar Project. It was North Dakota's first community solar project, a 102-kilowatt array, about 324 panels.
Okay, so there's already a foundation there.
Right. And what's interesting is that this existing project, Prairie Sun, could serve as a kind of potential testbed for adding this rain-powered capability later on.
A hybrid system.
Exactly. It shows Fargo is already committed to renewables, and upgrading to a hybrid system could mean much more consistent energy, rain or shine.
So wrapping this up, this deep dive really shows the, well, the real promise of rain-powered solar, doesn't it? Especially for places like Fargo with these really variable climates as the technology keeps developing.
It really does. And it leaves us with a final thought for you, the listener. We've talked about Fargo's specific challenges, but think bigger. How could this kind of technology change the game for renewable energy in any region around the world that deals with unpredictable weather, making clean energy truly reliable, no matter if it's sunshine or rain?